Alright guys, welcome back. So 6.5 is all about graphing secant and cosecant functions. So these curves are actually based on the sine and cosine graphs. Cosecant is 1 over sine, secant is 1 over cosine. So you can see what's happening is if you were to graph, for example, in green there, the sine curve, cosecant, the u's are created by the cosecants, are the peaks and values of the sine. And then there are vertical asymptotes, because you would be dividing by 0 there, where the sine is 0. And the same thing is happening with secant. You'll notice that we're starting here at 1 for cosine. And then here is where you have the vertical asymptote value, going down to -1, back up to 0, where again there's another vertical asymptote, back up to 1 for the cosine curve, and that's how we're creating the U shapes there for secant. So the whole goal is to essentially graph sine and cosine and then go at it from there. So because they're based on sine and cosine, you'll find while they will say SEC for secant, CSC for cosecant, the horizontal phase shifts are found in the exact same manner as sine as cosine. There is technically no amplitude for secant and cosecant graphs because they go on forever. We will still identify an amplitude based on the sine and cosine as we make part of the getting the coordinate points, but there's technically no amplitude for secant and cosecant. And the period is like sine and cosine, 2 pi over b. So again, in my opinion, and this is not the only way you can graph these things, but in my opinion, the easiest way, the best way to graph secant and cosecant is to graph the corresponding cosine and sine graph, where secant matches to cosine, cosecant matches to sine. You'll find the vertical asymptotes that you need to create to help separate the u's are based on the points that correspond to the midline, whereas the max and min points of the secant and cosecant graph match up with the max and min points, the peaks and valleys of cosine and sine. So if we have this graph right here, we're going to essentially graph what would y equals 2 sine of 4 theta look like. And then using those points, we'll make the cosecant graph. So because we are talking about sine, we do need to identify the amplitude, which is 2. And our period is 2 pi over 4, which is pi over 2. So again, there's no horizontal and vertical shift going on right now. So we're going up as high as 1, 2, and as low as -2. With our 4 horizontal values of pi over 8 for the quarter period, pi over 4 for the half period, 3 pi over 8 for the 3/4 period, and pi over 2 for the full periods. And then when we plot out those points, we're plotting out starting at 0 for sine, going up to 2 because it's a positive 2a value for next point, back to the mids, down to the valley, back to the mid. And unlike the sine curve, we're not going to connect those dots to make the U. We're now going to plot out our vertical asymptotes and then make the U shapes that go from that. The points on the midline, on that horizontal axis, are our vertical asymptote values. So obviously one of them is along the y-axis. Don't drive yourself nuts drawing that. Just recognize you don't cross the y-axis. The other two are occurring at the other two midline points. And then we do an upwards facing U for the point that's above, and a downwards facing U for the point that's below. And that's all we got to do. If we were to, again, extend the sine curve in both positive and negative directions, you'll just create more u's and more vertical asymptotes based on that information. All right, looking at our next example here, we have y equals -5 cosecant of theta over 3. So again, we're considering what would be -5 sine of theta over 3. The amplitude of that being an absolute value of -5, which is 5. The period of that being 2 pi over 1/3. Which is 2 pi times 3 over 1, which is 6 pi. Again, only looking at the positive portion here. We can recognize we're going as high as +5 and as low as -5. Our 4 horizontal values, same as we were doing in 6.4, the quarter period would be 3 pi over 2. The half period is 3 pi, 3/4 is 9 pi over 2, full period is 6 pi. And then for our coordinate points, sine again starts at 0, goes to the value of a, so it goes to -5, and then it goes to the midline from there, to the peak from there, and then back to the midline. And now to make it a cosecant graph, since all the other information is the exact same, we recognize we have vertical asymptotes along each of those midline points. And then we have U-shapes at each of those other points. And there's our graph for cosecant. All right, secant, very similar process. We're going to recognize now this one, because it's secant, is based on cosine. So we're really considering what are the points from -4 cosine of theta over 2. So for that one, our amplitude would be the opposite of -4, which is 4. Our period is 2 pi over 1/2. 2 pi times 2 over 1, which is 4 pi. And then we're plotting those points, again, only considering the positive side of this. We get, and we're going as high as +4 and as low as -4 for the y's. So we're recognizing we're going to have a quarter period of pi, half period of 2 pi, 3/4 period of 3 pi, full period of 4 pi. So now we're plotting out those points. Cosine starts at A, so it starts at -4. Since it's on the bottom, then goes to the mid, to the top, to the mid, to the bottom. Like with the cosecant, the vertical asymptotes are occurring at those midline values. Our u's are being created at those points, so we have our upwards facing u there. We're going to have two downwards facing u's on the left and right hand sides. If you wish to find the actual vertical asymptote that goes with it, you certainly can. Just simply following the rest of the pattern there. So like we have vertical asymptotes at pi and 3 pi, so the next one would be at 5 pi. So if you wish to create that one to help show what the right side looks like there, we would also have one in the negative direction at a -pi. So then showing that one right there is where it's ending on the left-hand side. You could do that if you wish. It's unnecessary. I do need to see both u's on the bottom in addition to the u up top. I just don't need to see the additional vertical asymptotes there on the edge. So just recognize they're a downward u because the point is on the bottom, and don't worry about the fact there's no vertical asymptote to cut off on the one side. Just do a simple u shape, make it look roughly symmetric. All right, so that's our secant graph. Let's do another one kind of like that. There we go. So we have y equals 2 secant of 6 theta. So we would be graphing points based on y equals 2 cosine of 6 theta. So our amplitude would be absolute value of 2, which is 2. Our period would be 2 pi divided by 6, which is pi over 3. So when setting this up, again, we're not considering any negative sides. We have our quarter period, which would be pi over 12. Our half period, pi over 6. 3/4 pi over 4. And then full period, pi over 3. Going up as high as 2 and as low as -2. Cosine, once again, starts at the value of A. Since A is the peak, it then goes to the mid, then to the valley, back to the mid, back to the peak. Where again, we have vertical asymptotes at all those midpoints, midline points. The bottom point is a downward facing U. The upwards points, the top points are the upwards facing U's. Again, I do not need to show the vertical asymptotes on either side there. You are welcome to, but I would accept full credits. I'd give you full credit for a graph that looks kind of like that right there. All right, so those are the basic cosecant and secant graphs without any sort of horizontal vertical shifting. So when there are horizontal shifts and vertical shifts, we still go through the same process we did for the sine and cosine graphs. We're still going to graph this based on -5 sine now of theta over 4 plus pi minus 1. We're still recognizing our amplitude and our period and everything else. So amplitude is the absolute value of -5, which is 5. Our period is 2 pi over 1/4, which is 8 pi. And it's going to be shifting left when we do this, so I'm going to leave some room on the left-hand side. So our 4 points, and it's going to go up as high as +5. And it's going to go as low as -6, because while it's a 5 there, it's also going to be shifting downwards, so I want to show that. Our quarter period would be 2 pi. Our half period is 4 pi. 3/4 period is 6 pi. Full period is 8 pi. So the original points for sine would start at 0, then go to -5, then go back to 0, up to 5, back to 0. And as for the shifting, remember that's based on factoring. We take the 1/4 away from theta and pi. Doing pi divided by 1/4 is pi times 4/1, which is 4 pi. So our horizontal shift is 4 pi to the left because of the plus sign, which 4 pi is 2 spaces. So it's going to shifting left 2 spaces. So I need to account for 2, sorry about that, negative spaces, so a negative pi and a negative 2 pi. The vertical shift is just the -1 at the end, so it's 1 down. So each of those points are now going to shift left 2 and down 1. So there's point 1. Left 2 down 1, there's point 2. Left 2 down 1, there's point 3. Left 2 down 1, there's point 4. And left 2 down 1, there's point 5. But we got to remember, the vertical asymptotes are occurring at the midline points. We're originally 1, 3, and 5, so now there's still 1, 3, and 5 here. The ones in the middle. Again, still got a vertical asymptote at the y-axis, so again, don't drive yourself nuts with that. Still going to have the top point being upwards facing you, and the bottom point being a downwards facing you. And there's our graph. So it's a little more complicated because we're shifting points around, but it's still the same process, same as we did for the regular sine graphs. Plot the original points without the shifting, plot the new points now with this horizontal and vertical shift, but now create your vertical asymptotes and use based on how the cosecant graphs are supposed to be done. All right, so let's do another one like that, plus a couple of secant ones. So here we're going to be graphing this one based on y equals 3 sine of 5 theta plus 3 pi over 2 minus 1. So the amplitude of the original sine would be 3. Our period is 2 pi divided by 5. It's a plus sign there, so this one's going to also go left, so I'll make sure there's enough room to go left. Our 4 spaces there. So the quarter period would be pi over 10. The half period is pi over 5. 3/4 is 3 pi over 10. Full period is 2 pi over 5. It's going to go as high as 3. And it's going to go as low as -3. It's actually going to go as low as -4, though, because the -1 shifted downwards. So the original points would start at 0. Because a is a positive 3, then go up to 3. Back to 0. Down to -3. Back to 0. As for the new points, they're now based off the shifting, so we're factoring. Taking 5 away from 3 pi over 2, you're doing 3 pi over 2 divided by 5, where when working in fractions means multiply by the reciprocal, 1/5, which is 3 pi over 10. We can recognize that 3 pi over 10 is going to go left because of the plus sign. It's also the third point there, so we're going to shift 3 spaces. Our vertical shift is again the -1, so it's 1 down. So each new set of points, we're going to go 3 spaces left, so I need 3 negative spaces there. Again, the negative side is just simply the reflection of the positive side with negatives, so it would be a negative pi over 10, a negative pi over 5, and a negative 3 pi over 10. So our new points are now going to go 3 spaces left and 1 space down. So point 1 is going to go there. Point 2, 3 spaces left, 1 space down, is going to go here. Point 3, 3 spaces left, 1 space down, is going to go right there. So if you want to write, actually, I'm kind of seeing like going to have kind of a mess right there. I'm going to go ahead and fix where I'm putting those. I'm going to put the negative points above the x-axis, -3 pi over 10, negative pi over 5, negative pi over 10, just so they're not interfering with where I'm actually placing the dots for point 1, point 3. I'm going to have to also fix the pi over 10 here. I'm going to need that spot also. I'll put that above. That just so you're not getting confused on where the points are and everything else. All right, so point 4 again is going 3 to the left and 1 down, so it's going to go down to here. And then point 5 goes 3 to the left and 1 down right there, which is why I moved to the pi over 10 location so you don't get like in the point on top of it. All right, so again, midlines are our vertical asymptotes. So make sure we clearly have our vertical asymptotes there at -3 pi over 10, negative pi over 10, and positive pi over 10. Upwards u's at the top points, downwards u at the low bottom points. Making sure, again, it's clearly showing that upward U starts at the negative pi over 5, 2 spot, and the other one starts at 0, negative 4. All right, so that's our cosecants. Next up is the secants. Again, same exact process going on here. And really, if you've not tried some of these on your own yet, you really should be pausing the video and giving this a shot on your own. Math is all about doing. Watching is fine, but you have to actually do it to really understand math a little bit better. All right, so our period is 2 pi over 3. The amplitude is 3. It's a minus sign, so we're only going to shift right, so I'm not going to worry about any negative coordinate points here. So we have our 4 points. We're going to go as high as positive 3, actually as high as positive 4, because it's a plus 1 shift. And as low as negative 3 for the original. The quarter period, so a quarter of 2 pi over 3 is pi over 6. The half period is pi over 3. The 3/4 period is pi over 2. And then the full period is our 2 pi over 3. Recognizing that for cosine, our original point starts at A, so it's going to start at 3. There's our first point. It's then going to go to 0, then down to negative 3, back to 0, and back up to 3. Our shifting now is going to move those points around based on the minus pi part and the plus 1. So we factor the 2 away from the theta and the pi. Doing pi divided by 2 means pi times 1/2, which is pi over 2. So our horizontal shift is going to go pi over 2 to the right now, because it's a minus sign. We're recognizing that our pi over 2, oops, and I just realized I kind of messed up a little bit with the horizontal values there. It's 2 pi over 2 here. I'm going to kind of erase the horizontals. Give me a second. Sorry about that. So it was 2 pi over 2, which is just simply pi. So the horizontals should be pi over 4 to start, then pi over 2 for the middle, 3 pi over 4 for 3/4, and then full pi for the full period there. So the pi over 2 is the second one, so it's going to be 2 spaces. And then our vertical shift is going to be 1 up. So each point is going to go 2 spaces to the right, so I need 2 more points here. Recognize our pattern is going up by pi over 4, so this would then be 5 pi over 4, and then 6 pi over 4, which is 3 pi over 2. So each point goes 2 spaces right, 1 space up. So point 1 goes here. Point 2 goes there. Point 3 here. Point 4 there. And then point 5 over here. Again, the ones in the middle are your vertical asymptotes, so I'm going to go ahead and do those vertical asymptotes. The one on the bottom is your downwards facing U. Points up top are the upwards facing U. Again, don't worry about a vertical asymptote on the left side of that, or on the right side of this other one here. Just simply draw those 2 U's. And there we go. There's our secant graph. Just make sure you're using the correct value of B, like I didn't do initially, but I did manage to fix that. So you're a little more careful with that. All right, so one more. So this one we have negative 2 secant of theta over 2 minus pi over 2 plus 4. So we're going to graphing based off negative 2 cosine of theta over 2 minus pi over 2 plus 4. So based on the cosine function, the amplitude is positive 2. The period would be 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. So when we graph this thing, it's also a minus sign, so we're going to only worry about the positive axis here. So we have our 4 horizontal values. We're going to reckon we go as high as positive 2, really as high as positive 6, though. I need to make this a little better. I didn't really space it out properly. Let's try that again. So again, we're going to go as high as a positive 6 because of the whole plus 4 with the amplitude of 2. There we go. That's better. And then we're going to go down as low as negative 2 based on the original value of A. And again, we have our 4 spaces. Based off the quarter period, so a quarter of 4 pi would just be pi. Half would be 2 pi. 3/4 is 3 pi. Full period is 4 pi. So the original cosine would start at A, which is negative 2. It It would then go to 0, then go up to positive 2, back to 0, back down to negative 2. The horizontal and vertical shifting now will change those points. So the horizontal shifting, we factor out the 1/2 away from theta and from pi over 2. So doing pi over 2 divided by the 1/2 means you're doing pi over 2 times 2 over 1, the keep, change, flip, multiplied by the reciprocal, which is just pi. And again, as always, with all these problems, we've been factoring out the b value to figure out the horizontal shift. If you're ever unsure you factored correctly, just distribute it back. 1/2 times theta is theta over 2. 1/2 times pi is pi over 2. That matches, so we have it okay. It's a simple check. So we can recognize we're going pi to the right. Pi is simply the first value, so it's only one space right. Our vertical shift is 4 up, so we're going to be going 4 spaces upwards. So each point is going to go 1 right and 4 up, so point 1 is going to go here. Point 2, 1 space right, 4 up, so it's going to go up to 4. 3 is going to go 1 right, 4 up, so it's going to go up to the top of the graph at 6. 4 goes 1 space right, 4 up, so it's up to here. And then 5 is going to also go 1 space, so we need a second space there. The pattern is going up by pi, so this one will just be a 5 pi. If you want to do more, that's fine, but we only need 1 additional space because you're only going 1 space right. If we're going 2 spaces right, we need 2 additional spaces. If we're going like 3 spaces right, we need 3 additional spaces. And if we're going left, same thing, but on the negative side. Anyway, so point 5 goes 1 right and then 4 up. So it's right there. Again, the points in the middle are your vertical asymptotes, so that's at points 2 and 4. And then the point up top is the upward geom. Points on the bottom is the downward geom. Again, don't worry about the fact that it's not being defined on the left side for at point 1 or the right side for point 5. Just recognize they're both downward u there because the point is on the bottom. And there's our secant graph, all based on sine and cosine. So as long as you're comfortable with those two, these graphs really are not going to be that bad. All right, so only one more section left, the video for the tangent and cotangent graphs. These are now going to be still similar, but also completely different at the same time. So they're not going to use the information we've been doing here, at least to find points. There are going to be new ways to find points for those. So I'll see you guys next time with that particular video.